Well, hello, everyone, and thank you so much for the kind introduction. And I'm really thankful for the opportunity to be here today and kind of share my perspective on these issues that I think are going to be of the utmost importance in the coming years. So just a quick little bit of background on myself. I'm a mathematician by training, so somewhat at odds with the rest of the disciplines here, and happy to share that perspective and learn from other perspectives as well. And I started my PhD research back in 2015 when the election that we've spoken a lot about today already was occurring. And this was a study that I saw right as I was beginning my thesis research that really, and kind of trying to think about what I might have to say with all of the new mathematical tools I had learned. This study from MIT really struck me. And the structure that you see here is one that we've been speaking a lot about today in different guises. I really like the cave analogy, and I think I'm going to steal it, but I refer to it as an echo chamber, and that's pretty prevalent across the literature from my point of view. So I became interested in, so what we're looking at here is essentially a map of Twitter during the 2016 election, right? And all that we're visualizing here, the nodes here are users and the links between them represent following, right? And they're colored by whether they followed Trump or Clinton. And when you color this map very simply like this striking structure emerges, right, of these pretty consolidated two groups with very little crosstalk between them. And I became very interested in, okay, so what type of mathematics, A, might describe this type of process, and B, how might you suss it out of the data that is now widely available to us through social media and the internet and the advent of all of this new type of media. So I'm going to talk to you today first. I'm going to try and convince you that, talk to you a little bit about what I think and, what the consensus is, the landscape of today's social media looks like, how that landscape is very susceptible to those who might aim to polarize us further, and the role that AI might play in such a process in both exacerbating that problem and hopefully aiming to combat it as well. So, maybe I should have renamed this slide Caves in Social Media, given our discussion today, but I think they're completely analogous concepts. And the takeaway from when you study the literature is that social media, especially around ideas of ideology and politics, users really participate in these caves and echo chambers to a large extent. And what that means is they really are only exposed and expose themselves to opinions with which they already agree with to some extent. And much has been made about the platforms themselves, their roles in creating and promoting these so-called filter bubbles, and that role is large. All of these platforms are optimized to increase engagement. And if that is your goal, the correct and smart thing to do is to serve people more content that they've already demonstrated that they engage with. But there's also, so that dynamic is very much at play, but there's also a lot of evidence to suggest that there is a self-organizing dynamic at play as well. We have an affinity to behave this way. And there's a lot of evidence for that, but some of the most convincing pieces I've shortly summarized here is that, you are still exposed to a certain extent on any platform to content that you don't agree with, right? And there will be some that say that is evidence that these filter bubbles are overstated and they don't really exist. But what you find is when you look at the engagement with such context, the echo chamber completely reemerges, right? So users really strikingly only engage, like, share, whatever the tools of the platform in question are, with the content that they've already demonstrated in affinity to. And what's more, if they do engage and share with content that is seen as cross-cutting within their community, there's evidence that they're punished for that in the sense of reduced network centrality and reduced engagement with their own content, which, our dopamine receptors do not like when we are on the internet. So I think that a lot of this can be summed up in what the mathematical literature calls a bounded confidence assumption, right? And this is quantified on many different axes and topics, but the main thrust of it is that my confidence in another person is bounded to a point of certain agreement, i.e. I will not engage and interact or engage with a consensus process with another person unless I perceive them as a friend to some extent. So, and I promise, I won't promise no math, but I will promise it will be mostly painless. So now that, I've described this landscape to you, I'd like to convince you with some of the, mathematical work that I've done that it is especially susceptible to the types of polarization processes that we've been talking about today. So the framework that I like to work in to most usefully describe the types of processes that we see emerging in Twitter and all across social media is borrowed from statistical physics, right? Where we treat individuals and their opinions as a system of particles that interact in a pairwise way. So my opinion, I move towards some type of weighted average of those who I interact with in a social network, and that might be I might be feeling pushes from people I disagree with. I might be feeling pulls from people I do agree with. And this is pretty much captured in this very general equation right here. So a bounded confidence model is a special case of such a model where we really feel no pushes at all from everyone. If we interact with someone, we reach a consensus in some sense. And I move my opinion towards the average of people that I interact with, right? But the caveat is I'm only willing to interact with someone in the first place if their opinion is within a perceived threshold of mine. So what this introduces into the network is that the network structure almost completely exactly corresponds to the distribution of opinions at that time, right? And this assumption that I will only interact with people within a threshold forces the network to assume what in the literature, and I love this word as well, a homophilic structure, i.e. birds of a feather flock together. And due to the attractive nature of the interaction rule, the generic behavior, and this has been proven in 12,000 different ways, is an emergence of clusters or echo chambers or caves or whatever you would like to call them. So another thing that the theory teaches us is that if you are a polarizing agent, i.e., and I'll define that here as an agent who will exert influence on the population, but does not feel an influence in return, they maintain their opinion artificially no matter what with the goal of polarization, you can have a very striking effect very quickly on these types of polarized network structures. All you have to do is hold firm and wait for the people within your orbit to come here. And the polarization strategy that I've shown here is very simple: sit at the fringes, radicalize the people that are susceptible to that fringe influence. But indeed, it could be made, the situation could be made worse if this strategy was more sophisticated and the polarizing agents distributed themselves across the spectrum of opinion. And if that were the case, indeed, we would see that middle component be fragmented as well. So given that situation in the theory, the theory question becomes, can we introduce a strategy to prevent that from happening, right? And the idea is that this bounded confidence assumption, which there's evidence for, it results in these clusters, but it also allows for the possibility of moderating agents. And the idea, yes,
in your previous slide.
Sure.
That far left and far right.
If you want to, whatever situation you'd like to project on the model here, feel free. But yes, that you could have that in mind. Exactly.
Okay, but do they interact, and is there a possibility of interaction between them?
Well, that's exactly the idea that you want to introduce back to prevent this type of polarization. So like I said, this type of dynamic results in a homophilic network structure. The network becomes very disconnected and fragmented. So the intuition is to prevent that type of clustering from happening, we need to have agents who are resistant to that fragmenting of the network, i.e. they otherwise evolve according to the normal dynamics, but they are especially sensitive to their local network. And when they sense a breakdown is about to happen, they stop adjusting their opinion in the way that a polarizing agent does. And then once that breakdown, risk of breakdown has gone away, they resume their normal activities, right? And this is actually, these types of agents, these moderating agents, in the theory are kind of provably optimal way to reintroduce consensus under these types of dynamics. And you'll notice that a main difference that these moderating agents have from the polarizing agents is that they do eventually start to adjust their opinion in response to the population again. So the theory tells us in short, right, that the situation is bad, but there is some hope given given that we can introduce this type of dynamic. However, I'm going to turn away from the hope for a second and talk to you about, so through gathering data and doing more empirical work on these types of things, I tripped into developing some expertise in AI because analyzing large swaths of text data necessitates that type of analysis, right? And through learning some tools of the trade, it became pretty clear to me that they could be, they have a joint capability to produce these polarizing agents at scale. And while it's unclear if that capability has been deployed yet, I think that it's an inevitability given the way that the field is evolving. I mean, we're solving the problems fast and well. So before I convince you of that framework, I want to introduce to you a couple tools of the trade from AI. So the first one is language modeling. And broadly, the goal of language modeling is, okay, down the line, we would like a computer to generate text that is both salient and believable given a topic, right? But before we can do that, we need a way to statistically represent language to the machine in a way that is meaningful, right? And that is the task of language modeling. How do we represent text in a way that a computer can interpret it and be useful? And pretty much all downstream tasks, anything you might want to do in an automated way with AI or any computer concerning natural language starts with this type of process. So I'll give a simple example of a language model. I mean, the ones used in practice today are complex, but they still have this idea at their heart that we want to represent words or chunks of text in a way geometrically where their space and their distance in some latent space corresponds to their meaning, right? And in that way, we can use the geometry of the space where we represent the text to extract meaning from the text that we are analyzing in a way that we can regenerate it using a computer. So an example here, just a very simple one, right? A good representation of these three words, king, queen, and orange, right, would result in the words king and queen sitting very close to each other in this space and much farther from orange given their disparate meanings. But the question is, how do you define that? Like, that's a nice notion, right? But how does one define this statistically in a way that is meaningful? And here we borrow a hypothesis from linguistics, which is that it's called the distributive hypothesis. And the idea is that meaning and context are kind of dual concepts, i.e. two words will have similar meanings if they occur in similar contexts. And here I mean context in a very, very simplistic way, like literally some kind of window around the words in question. So if two words appear around a lot of the same words, it's reasonable to assume that those two words share a meaning, right? And all of a sudden, now we have a statistical way to measure context, and if the distributive hypothesis is true, ergo measure meaning, right? And that all just comes from looking at word co-occurrence in large text corpuses. So the whole game then becomes, to train these models that can eventually generate text, the game becomes, okay, show me a context, I'll predict the word, or vice versa. Pretty much all the training processes for these models are some complication of that base idea. And for the case of generative models, there's a very specific context that we want to choose, right? You know, words are just a string of symbols, right? And here, if we define the context of a word as some window of words preceding it, we can ask a model to learn the task given obviously a large collection of text. I'm going to show you 6 words, tell me the 7th. I'm going to show you 2 words, tell me the 3rd. A somewhat Mad Libs-like task, if anyone knows the book, right? So once a model has learned to do this task reasonably well, the task of asking it to generate salient sentences becomes pretty simple mathematically. It's just sampling a learned distribution of what word comes next given the preceding words. And you know, the generation happens exactly akin to this. I tell the model hello. It knows that it's a very high likelihood that the next word is going to be my, and then I tell it hello my, and then, you know, because it's read a lot of words, it knows that it's very likely that the next word is going to be name, and so on and so forth. And I've described this in a somewhat simplistic way, but the fact of the matter is that these models today are extremely expressive, extremely salient, and are generating some pretty impressive things, summarizing large swaths of text, replying to conversations, and even passing the Turing test in some very limited circumstances, so on and so forth. So the point is that this framework, given a sufficient amount of data, which the internet provides, and given a sufficient amount of computation power, which is the bottleneck, but I think that will soon be overcome, you can generate text in a very expressive way. But that by itself, for the purpose of running an influence campaign or encouraging polarization, is not enough, because you need to be able to control the types of generation that you're doing. You just don't want to let these models run away and say whatever they would like to say, right? You would like to shape the campaign in a way that is useful, using, you know, expertise that is beyond just a statistical understanding of words. So AI, the field of AI, has another tool for this called topic modeling. And, you know, this goes way back into the 80s, but it's becoming more and more sophisticated now. And I'll talk less about the methods here and more about the output. And the idea is, given a large collection of text, right, you would like to know what is it talking about in a more meta abstract sense. And the way that computer scientists in the AI community have decided to solve this problem is in a 2-step process, right? Identify words that are particularly imbued with meaning, right? And then cluster them together into meta topics, and then give those topics names. And then once you've done that, given arbitrary text, you can sort it into those topics based on the occurrence of the phrases that you found in the original training set. So I've actually given you a small example of, this is an actual topic model that Hassan and I computed on a translated set of Ukrainian blog data. And you can see it's, you know, pretty salient. It's capturing the meta concepts fairly well. And, you know, that's a button push, and you wait 2 hours and it's done. But the final ingredient is you want to be able to talk about these topics in a charged way, right? If you're going to craft any type of polarization or indeed consensus process, right, you need to be able to imbue these topics with sentiment, right, to invoke an emotional response, right? And the field has an answer for that as well. It's, you know, like all things, an evolving process, but sentiment analysis aims to do exactly that. And it kind of comes in 2 flavors that I found in the literature. Measure the sentiment of a whole group, like a whole chunk of text, right? And tell me whether this tweet is positive, negative, or neutral. But the more dangerous and or interesting and or useful, whatever adjective you'd like to put to it, flavor of sentiment analysis is, given some of the important words and phrases that you measured in topic analysis, compute the sentiment of those phrases compute the sentiment towards those phrases relative to the chunk of text, right? So instead of computing this, I hate apples and love bananas as a neutral sentiment because it has hate and love, we can say that we're happy about apples and mad about bananas in this sentence. So this finally brings me to the framework that I worry about and also maybe could be deployed in more of a moderating sense. With one of those sentiment charged topic models in hand, and people with expertise like yourselves, you can almost create kind of an algorithmic modular campaign, right? I see someone talking positively about this topic. I can coalesce by talking positively about the thing that they spoke about and about the target topic that I would like to adjust their opinion on. Vice versa, I can insert a wedge and drive them away from their expressed opinion. And the point is that once you deploy all of those tools at scale, you can do this arbitrarily in any population that you would like, where you've measured a sufficient amount of topic clustering. So here is an example of what this might look like from the gun debate in the gun control debate on United States Twitter, right? So these are all, so again, the nodes are users, the links are followings and retweets, and they're colored by sentiment analysis of their content on the gun control debate. Now, the interesting thing about this is the yellow agents here are users that were found to have a statistically significant different set of behavior than an average user on Twitter. They tweet prolifically, they follow prolifically, and the assumption is that it's an automated process. So here they weren't posting any content, they were merely retweeting, sharing, and amplifying the conversation, but you can see the effect that it had, right? So if you add actually salient speaking into the mix, things don't get better, I think. But, we can fight fire with fire in a sense, right? Because all of these same tools can be turned around to measure these types of campaigns, deploy moderating agents, but there is theory as well that suggests that adding moderating agents in the presence of polarizing agents is not enough. There's an upper bound in the amount of consensus you can reintroduce, and you need to do something to neutralize the polarizing agents and naming and shaming them based on what you've measured and what you found is one possible way, and real-time debunking of any mistruths that they might be selling is another. But this is something that I would love to discuss further with you guys after, in the spaces that we have. So thank you so much for your time. I'm afraid I might have gone a little bit early, but a little bit over, but I'd love to talk to you guys whenever we have the chance.